Okay, now I want to combine those two ideas, weighted average and standard deviation of a portfolio standard deviation using correlation with value at risk. So let's assume I have a portfolio with about $10 million invested. Okay, so I have $10 million invested in this portfolio. It's 30% stock, 70% bonds. My stocks earn 15%. My bonds earn 7.4%. My standard deviation of equity is 25%. My standard deviation of bonds is 7%. And I've got a correlation. Let's do a rather small correlation here. Let's do 0.35. Okay. So what is my return? Well, the way I taught you was you do return of one. I'm doing plus, it should be times the weight, return of the other, times the weight, and the sum of that is your weighted average. So the weighted average of returns, this portfolio's return, 30% stock, 70% bonds, is 9.68. The portfolio standard deviation, first I'm going to do weight squared times standard deviation squared for one. Weight squared times standard deviation squared for the other. 2 times weight, I'm doing plus, it should be times weight times standard deviation times correlation. The sum of these and the square root. So my portfolio standard deviation is 10.29. All right, I'm going to need to know my critical values for 10%, 5%, and 1%. What do we mean by these critical values? Okay. If your basic bell curve, something kind of like this, how many standard deviations to the left do I need to go in order to only have 10%, 5%, or 1% underneath this area over here? That's what we're looking at. So for 10%, my critical value is 1.282. 1.28. For 5%, it's 1.6. Let's do it this way. For 10%, it's minus 1.28. For 5%, it's 1.64. And for 1%, it's 2.3. So let's use 1.28, 1.65, round it up just a little bit, and 2.33 as our values. Let me go back to Excel. I've got 1.65, 1.8, 0.33, 1.2, sorry, 1.28. Get this in the right order, 1.65 and 2.33. Now, my formula for value at risk, I have my return, I have my standard deviation of returns. My weighted average of returns is 9.68. My standard deviation of returns is 10.29. All right, I want to know 10% of the time I'm going to lose how much or more. So this is my return. I'm going to move 1.28 standard deviations to the left. And 10% of the time, I'm going to lose 3.5% or more. Which means that 10% of the time, I'm going to lose 349 or more. All right. Now, if I want to know how much I'm going to lose 5% of the time, because I'm moving further away, this is on this hypothesis testing, I'm moving further away. Then my loss is going to be greater, but it's only going to happen 5% of the time instead of 10% of the time. So let's anchor this one. H4 is this one, and I6 is this one. 5% of the time, I'm going to lose 7.41% or more, or this much or more, $734,000 or more. Okay. 1% of the time, now I have to go 2.33 standard deviations, I'm going to lose 14.31% or more. All right. So when we're changing from a 10%, a 5% to a 1% bar, all we're doing is moving how many standard deviations away from the mean we're moving. My returns stay the same, and my standard deviation stays the same. Now, how do I turn an annual return into a monthly return? In other classes, there's more formal ways to do it, but here we're going to do it just like that. So if my annual return is 9.68, my monthly return is 0.81. Here, instead of dividing by 12, I'm going to divide by square root 12. So we adjust our return, just dividing, and our standard deviation, dividing by the square root. All right then. So return minus the z factor, which is how many standard deviations we're moving. Actually, the z factor shouldn't have those dollar signs, times the standard deviation. Okay, I'm going to put dollar signs on the return. The dollar signs anchor the cell, and on the standard deviation. So now that I did that, I can just hold this down. So if 10% of the time, in 10% of the years, I'm going to lose 3% or more. Sorry, in 10% of the years, I'm going to lose 3.5% or more. In 10% of the months, I'm going to lose 3% or more. Since I moved from yearly to monthly, my monthly VAR is smaller than my yearly VAR, but my 1% VAR is larger than my 10% VAR. Let's do weekly. Return divided by 52. Standard deviation divided by square root of 52. These are my weekly returns and weekly standard deviations. Return minus the return anchored minus z factor times standard deviation anchored. So my weekly return, my weekly VARs should be smaller than my daily VARs. Sorry, my weekly VAR should be smaller than my yearly VAR and my monthly VAR. So 5% of the weeks, I should lose 216.946 or more. 1% of the weeks, I should lose 314.26 or more. Same thing for daily, except now instead of using 52 or 12, and since we're talking trading days, if we're talking, let's say a currency market, which is open all year long, I'd probably use 365. But since this is normal equity market, stocks and bonds in this case, I'm going to divide by 250, and I'm going to divide by square root of 250. Now I've made my returns and standard deviations into daily returns and standard deviations. It's the same formula. I could pull it down and just change the anchors, but I want you guys to see this again and again and again. So return minus my z factor times standard deviation. All right. So that I can just copy this one down, I'm going to anchor my return, anchor my standard deviation, leave the z factor unanchored. Those are my returns. I mean, that's my value at risk in terms of returns. And there we are in terms of dollars. So 1% of the days I should lose 146,000 or more. And you might say, yeah, but if you're saying 1% of the days you're losing 146,000, there's 5 days per week, and this isn't 5 times as big. Yeah, because you can lose 146,000 in one day, but you're not talking about losing that all in a week. For you to have 2 days, 1% days in 1 week is pretty incredible. So you're gaining and you're losing every day, but 1% of the days. In other words, out of a year, you should do this at least 2.5 times. You should lose that much or more. And that's fine. That's within your value at risk limits. All right, I hope these videos helped.